As we look at the natural world around us, the fact that dinosaurs once roamed the earth seems about as real to us as these guys. Sure, we can go to the Natural History Museum for a little while to glimpse into the past, to appreciate the strangeness of life millions of years ago. But what about how these alien creatures died? At first glance, the dinosaur extinction about 65 million years ago seems to have little relevance on the challenges that we face as humans today. Until recently, the prevalent scientific theory suggested that it was an asteroid impact that began the extinction that killed off all of the dinosaurs. This impact may have blocked out the sun, causing cooling and preventing photosynthesis for a number of years. But the story might not be so simple. As Gerda Keller, a professor of paleontology at Princeton University, who has been studying the KT mass extinction for decades, will tell you.
I think we all know that the common wisdom is that Chicxulub killed the dinosaurs.
And Chicxulub is the...
Chicxulub impact on Yucatan killed the dinosaurs 66 million years ago. Mm-hmm. And it's the sole cause for the mass extinction. Wrong.
In fact, Professor Keller believes that while the Chicxulub impact did happen, it had little to do with the mass extinction that killed off all the dinosaurs. Instead, she has found proof that the main culprit is in fact a prolonged period of volcanic activity called Deccan volcanism that lasted for hundreds of thousands of years around the time of the KT mass extinction.
We knew that it was huge eruptions, but we didn't know just how close to the KT boundary it was. Mm-hmm. And then, of course, it sort of got stuck and overwhelmed by the impact. I had worked a lot on the Chicxulub impact, and I had done all I could do, and I had convinced myself that the answers were elsewhere. Mm-hmm. And that elsewhere, the only other catastrophe was Deccan volcanism. Okay. So we went to India.
Professor Keller has very recently successfully pinpointed the timing of the most intense and active parts of the Deccan eruptions. The main sections of Deccan volcanism seems to have happened immediately before and also after the mass extinction. While Gerda Keller's theories were considered fringe in the past, her recent discoveries are forcing even the most adamant of asteroid theory supporters to admit that Deccan volcanism likely played an important role in the extinction alongside the Chicxulub impact. But how exactly does a long period of volcanism cause the majority of life on Earth to die off?
The mechanism would be, it has to go, the gases have to go into the troposphere and stratosphere. Mm-hmm. And from there it gets circulated around the world. In the past, we track it mostly based on climate change. Okay. And that means CO2. Oh. And also ocean acidification. Mm-hmm. And that's also from CO2.
Okay, so that's the main cause of volcanism.
Those are the main ones. In fact, we have 5 major mass extinctions. They're called the 5 big ones. Mm-hmm. And over between 66 and about 400 million years ago. And 4 out of the 5 are now intimately associated with similar Deccan-type volcanic eruptions.
4 out of the 5 major mass extinctions in the history of life on Earth, the past 500 million years, have been associated with intense and protracted volcanism and a serious increase in global temperatures and ocean acidification. When you strip it down to the bare bones of the problem, too much CO2 in the atmosphere in the past has led to catastrophe for almost all life on Earth. Since 1750, we, as humans, have released 2,000 gigatons of CO2 into the atmosphere. In comparison, conservative estimates of the total CO2 released during Deccan volcanism fall around 28,000 gigatons of CO2, roughly 14 times more than the CO2 we've released into the atmosphere. But Deccan volcanism lasted for more than 200,000 years, while we've only been at it for 250 years. If we assume a constant rate of emissions, human beings have been releasing CO2 into the atmosphere 70 times faster than the eruptions that probably killed the dinosaurs.
I think there is not much of a question that we are in the 6th mass extinction. If you look at the way we are eliminating species today, along with the forests like the Amazon and Indonesia and all the tropical forests that are hosting most of the diversity. And the oceans are getting overfished, etc. For critters that need calcium carbonate for living, it's already today, it's too acidic to produce the shells. And the interesting thing is that before the mass extinction at the end of the Cretaceous, we see exactly the same. Species dwarfing, trying to adapt, thinner shells, and disappear, and very low abundances, decreased abundances, and then eventually.
And no challenge poses a greater threat to future generations than climate change. Now, 1 year doesn't make a trend, but this does. 14 of the 15 warmest years on record have all fallen in the first 15 years of this century. I've heard some folks try to dodge the evidence by saying they're not scientists, that we don't have enough information to act. Well, I'm not a scientist either. But you know what? I know a lot of really good scientists at NASA and at NOAA and at our major universities. And the best scientists in the world are all telling us that our activities are changing the climate. And if we don't act forcefully, we'll continue to see rising oceans, longer, hotter heat waves, dangerous droughts and floods, and massive disruptions that can trigger greater migration and conflict and hunger around the globe. The Pentagon says that climate change poses immediate risks to our national security. We should act like it.
The difference between us and the dinosaurs is we are our own volcano, and we have the potential to mitigate the effects of global warming by making an effort to reduce our emissions. We need to take action to control the trajectory of the current mass extinction. The fate of the dinosaurs does not need to be our fate.